You know the drill. You sit down in the chair, feel that little pinch in your arm, and just like that, it's done. But right as that vial of blood gets capped and whisked away, a whole secret journey kicks off. Today, we are going to pull back that curtain and follow your blood sample to uncover the incredible story of your blood test.
It really seems so simple, doesn't it? A needle, a tube, a bit of gauze, and you're out the door. But that little sample is about to go on an amazing trip. Think of it like a high-tech detective story, where your blood is the main character, and the mystery it's solving is all about your health.
And here it is, our hero. This one little tube. Looks simple enough, but it is packed with literally thousands of biological clues. This vial is the key to understanding everything. From your nutrition to how well your organs are working, its journey from your arm to that final report is just a marvel of precision. So our story starts right at that moment of collection. Let's call this first chapter From Arm to Lab. It sounds straightforward, I know, but you're about to see how the success of the entire analysis depends on getting this very first step absolutely perfect.
This procedure is called a venipuncture, and believe me, it's way more than just poking a vein. The phlebotomist, that's the person drawing your blood, is actually the first guardian of your sample's quality. Their technique can literally make or break the whole test before it even gets close to a lab. Yeah, this isn't some casual thing. It is a super controlled checklist, and every single step is critical. They have to confirm who you are with at least 2 different methods. Pick the exact right tube for your test and label it right then and there, never after you leave. This whole routine is what guarantees the sample is yours, that it's in perfect shape, and that it gets to the lab ready to go.
And hey, have you ever noticed all those different colored tops on the tubes? Well, they're not just for looks. They're actually a crucial code. Each color tells the lab about a specific substance or an additive that's already inside the tube, preparing your blood for one specific type of analysis. It's a pretty brilliant system. So, for example, a purple top has something in it called EDTA. That's an anticoagulant, which just means it stops the blood from clotting. That's super important if the lab needs to look at whole blood or plasma. But a red or a gold top, they have no anticoagulant. They're designed to let the blood clot, because for a lot of chemistry tests, what the lab really wants is that liquid part that separates out after the clot forms. And that liquid, that's called serum. All right, so this sample makes it to the lab safe and sound. Now, its first big transformation is about to happen. To get at all those chemical clues, the lab has to separate the liquid part of the blood from the solid cells. It is time for the great separation. And this is a centrifuge. It's a core piece of lab equipment, and it spins those blood samples at thousands of rotations per minute. This crazy fast spinning creates a powerful force that separates everything inside by density. The heavier red blood cells get pushed down to the bottom, leaving that lighter liquid gold right on top. And this spin shows you exactly why those color-coded tubes are so important. See in the tube on the left, the one with the anticoagulant, the cells just sink, leaving that liquid plasma on top. But on the right, where the blood was allowed to clot, all the cells get trapped inside that clot, and the liquid that's left over is serum. And that serum is the real star of our show today. It's basically blood plasma, but with all the clotting stuff taken out. This clear yellow fluid is exactly what the lab needs for the chemical tests we're going to look at next. You can think of it as a perfectly clean window into your body's chemistry. Okay, so we've got our pure serum sample ready to go. Now we get to the heart of the lab analysis. How do scientists actually measure all the different things floating around in that liquid? Well, the answer, amazingly enough, is light. Say hello to the spectrophotometer. This machine is the absolute workhorse of the clinical chemistry lab. It is an incredibly precise instrument that can figure out the exact concentration of a substance just by shining a beam of light straight through it. The basic idea here is just so elegant. Every chemical out there absorbs a very specific pattern of light. It's like a chemical fingerprint. So by measuring exactly which light gets absorbed and how much of it, the spectrophotometer can identify a substance and tell you exactly how much of it is there. So how's it work? A light source shoots a beam through a prism, which picks out one very specific wavelength of light. That single color beam then passes through the serum, which is sitting in this tiny transparent box called a cuvette. On the other side, a detector measures how much light actually made it through. It's simple, right? The more of a substance you have in the serum, the less light gets to the other side. It is a beautifully powerful way to measure the invisible. So, the spectrophotometer has done its thing and it's spit out a bunch of numbers. But what do those numbers actually mean? What kind of secrets can that serum tell us about our health? This is where it all comes together. The machine measures what we call analytes, the things being tested. Let's take calcium. It's vital for your bones and nerves. If your levels are off, it might point to an issue with your parathyroid gland or your vitamin D. Or look at iron. It's essential for carrying oxygen in your blood. Low levels could mean anemia, but really high levels? That might suggest a genetic issue or even poisoning. Every single number tells a piece of your personal health story. Now, so far, we've seen the perfect journey, but this whole process demands perfection at every single step. So what happens when something goes wrong? What happens when that precious sample gets compromised? Just take a look at this. On the right, that's a perfect sample. The serum is clear and pale yellow, exactly like it's supposed to be. But the one on the left? Yikes. That sample is red. This is really not good. This is what's called a hemolyzed sample, and for the lab, it is a huge problem.
Hemolysis is what happens when red blood cells get damaged and just burst open, spilling everything inside them into the serum. You remember how hard we worked to separate the cells from the serum? Well, hemolysis just contaminates that clean serum with all the stuff that was supposed to stay locked away.
And what causes this? Well, it can happen at almost any point in that early journey. Using a needle that's too small, drawing blood too hard, shaking the tube instead of gently mixing it, letting it get too hot or cold on its way to the lab, even just waiting too long to spin it down. This is exactly why that initial collection is so incredibly important. And this contamination completely wrecks the results. I mean, think about it. Red blood cells are packed with things like potassium and iron. When they burst, those things flood the serum, giving you falsely high readings that could send a doctor down a completely wrong path. At the same time, other things can be falsely lowered. The results just become totally unreliable. And the end result of a hemolyzed sample is pretty simple. The test is invalid. It has to be rejected. The lab can't report bad numbers, which means the entire process has to start all over again. And for the patient, that means another appointment, another needle, and another wait for results that are critical for their health. So the next time you get your blood drawn, you'll know exactly what's going on behind the scenes. That simple vial is really the start of a remarkable journey, a story of chemistry, technology, and meticulous care. A story that can only be told the right way, if every step is perfect. It really makes you think, doesn't it? What other vital processes in our daily lives depend on this kind of hidden, flawless execution?